This conference will now be recorded.
Yeah, this is what I wanted. All right. And we have got good evening, Firak, Sam. All right, good. Nice to see you all over here, guys. So before I continue with regards to where we left yesterday, yes, yesterday we had a couple of questions and those questions were answered. Some of the questions which require detailed answer, which requires connection with some other responses, definitely they were parked, and that's we have the leverage of doing it. So guys, the question is, if you have any question, if you have any doubt with regards to whatever we discussed yesterday, all right. If no, let's do one thing. Let's get started. This is Cisco ACI building blocks, which means that over here we are going to understand what are various components. In fact, yesterday we had a glimpse of it. Today it is kind of recap, which means yesterday we discussed that in Cisco ACI we definitely are going to have the switches known as leaf and spine switches, which will be connected in a redundant topology form. Oh, redundancy, spine, spine, leaf, 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 and leaf. The connectivity is north to south connectivity, right? If you expect a lateral connectivity is east to west, that is not possible. That's what we discussed. Now, then we discussed that the complete management, the configuration of this particular fabric is not on box by box approach, but it is going to be done by a device which is actually a server, and we call it as APIC, that is Application Policy Infrastructure Controller. This in production environment is supposed to be deployed minimum 3 in a cluster. You know what? These devices, they are the ones which form our ACI building blocks. As we discussed, how do they look like? These are the boxes. Access 9500 and 9300 and APIC controller. Let me have the honor to quickly show you something with the help of our beautiful friend called Cisco 3D Interactive Catalog. And we are going to take the help of Cisco 3D Interactive Catalog. This is indeed interactive in terms of it provides us leverage to look into the devices. I'm just going to show you the leaf and the spine switches, which we do use in case of our ACI fabric. And thank you so much to Cisco for providing us this facility wherein we can look at we can interact with many types of switches. Nexus 9000 series, if you look at into, and if we slightly go down, you can look at into Nexus 9504, Nexus 9508, and 9516. Well, in our day one class on Nexus hardware, we have already diagnosed, we have already dissected these switches. Let us take a look on 9504, which is our ACI spine switch. What exactly is it? Well, this is online. This is the switch, right? 9504, this switch is 4 slot switch for line cards, Line cards are placed in the front of the chassis in a horizontal position. Below the line cards, we do see the supervisor engine. Supervisor engine are half width supervisor engines, and they are the one which are placed at the bottom of the line cards. Rear of the chassis, if we go rear of the chassis, we happen to see the fan trace, and below the fan trace there are two cards. All right, there are two different cards if you see, and these cards are known as system controllers, SC1 and SC2. What is the function of system controller? Hope you remember, I told you function of system controller is to offload chassis from chassis management jobs. Offload the supervisor engine from chassis management job. Other than Nexus 9500 series switches, all the switches, the chassis management tasks is done by the supervisor engine. So this is such a beautiful chassis, and in this chassis it is well defined in terms of the optimal usage of supervisor engine as well. Well, in this particular chassis there is another component, right, which is hidden component behind the pantry. Let me take a look on it. I have zoomed the screen a lot, and that component is known as fabric module. Where exactly is a fabric module? If you take a look over here, fabric module is nothing but it is vertically placed card. Card is not the right word, it is a connector. It is a connector which ensures that our line cards are connected to each other, plus this particular connector or module ensures that line cards are connected to supervisor engine also. By the virtue of this particular module, we do call our Nexus 9500 as fabric switch. Well, we had a detailed discussion on it. In case we happen to come across once again in Nexus hardware technology classes, yes, we will talk about these switches in detail. So if you go back and try to, once again, let me quickly zoom in to right 100%. Yeah, perfect. Which switch now we are going to? Nexus 9396TX switch. Guys, 9500 series switches, Nexus 9500 series switches are predominantly meant for the purpose of ACI spine switches. Nexus 9300 series switches are for the purpose of to be placed for what? To be placed as ACI leaf switches. Now, please take a look on this particular switch from a more closer angle, which will tell us the purpose of it. If you take a look on this particular switch, 9396TX, it has got certain fixed interfaces, right? These interfaces are fixed ports. However, there is a card, there is a module which is inserted. What is the model of it? It is N9K M12PQ. Now, if you take a look on these ports which are on a lower DAC, there are total 48 ports, right? Now, those guys who have already attended our Nexus hardware classes, we discussed how to decipher, right, the naming convention of the line cards. You can easily make it out. However, now important thing is, what is the purpose of? Let me grab a pen or a highlighter. Mr. Highlighter, can you please come in front? All right, thank you. If you take a look on these particular ports, these ports are definitely different from these ports. right? So the question comes is, where these ports they do go? These ports, they are meant to connect this leaf switch with what? With the spine switch. One port goes over here, another port goes over here and connects to the another spine. If you have more spine switches, then and so on. Remember, guys, if you take a look on these particular ports, they require SFPs, small form factor pluggables. These ports, if you take a look on, the numbers are highlighted over here with yellow color. Any port number highlighted in yellow color signify that the port is of 40 gig capacity. This means the ports are of 40 gig capacity, and you know what? That is the requirement of connecting our leaf switches with our spine switches. So remember, in order to fulfill our clause architecture connectivity in ACI between leaf and spine switches, the north and south connectivity should be minimum on 40 gig links. A significant point. Now, what these ports are for? These ports are to connect to the servers, for example, or bare metal host machines, right? And these ports, you can say these are for the access layer connectivity. This is quite important and decent for us to know. We should be clear about the purpose of it. Let me clean this particular picture. So this 9396TX, right? On the front, you can see this particular switch has two different kinds of ports. Ports for connecting the spine switches and the ports for connecting the servers. The other devices, the firewalls, the load balancers, the bare metal host machines, etc. All these things are going to be there in our lab. All right. That means we will be working on the basis of physical connectivity, and that too in a virtualized world as well. All right. Can we connect leaf to spine with two cables towards each spine? That means you want two cables towards each spine. My dear friend, that's actually not required when you have 40 gig link already provided. And in fact, I have not seen this kind of connectivity. No. And quick answer will be no, instead of giving you any diplomatic answer. Rajan, right? Okay.
Ashish, I have a question.
Please, Umair.
Yes, if we connect servers over fiber 10G ports, so can we use breakout cable on this 40G and connect the servers?
Okay. You know what? All right, I got your question. You are trying to connect. Let me grab my highlighter. On these particular ports, you want a breakout cable and want to connect your servers.
Yeah.
Answer is no. These particular ports are for the purpose of leaf to spine connectivity and not for the purpose of connecting the servers. These ports are basically, you call them as uplink ports. Hope you remember, even in PACs, we do have dedicated ports for the uplink connectivity. So uplink ports cannot be used to connect with our access layer, right? So that's not possible, but in case if nothing is possible in the field of computers networking, so in case if Cisco has done any modification, probably we need to look at into the data sheet. Answers to certain questions are addressed by the data sheet as well. So if you note down the number, you go to Cisco Nexus 9396TX switch data sheet, you will be able to get the exact and the latest answer to the question. Right, Umair?
Okay, okay, Shiv.
All right. Okay, so important interfaces, and we go back. So as part of our building blocks, what we have got our 1, 2, 3 Cisco Nexus 9500 series switches. Plus we have got Cisco Nexus 9300 series switches for the purpose of leaf connectivity. However, there are certain leaf switches which are qualified to be used at the place of spine switches. Those leaf switches are specific in model and those are known as baby spine switches. What are those switches? The topology we have discussed. 9.5. Now, the baby spine switch, the connectivity we are well versed about. Let me show you the baby spine switches. Where are the baby spine switches? Oh, baby spine switches I discussed probably in Nexus hardware. So there are baby spine switches. For example, this particular, there is a model, sorry, the model I have not shown over here. 9336 PQ is a baby spine switch, which is qualified for the purpose to be deployed as a ACI spine switch. All right. Now there is a very common question which comes. In one ACI fabric, how many spine switches and how many leaf switches can we have? Guys, the answer is the version dependent. That is the controller. It is dependent on the controller how many switches a controller can handle. Right? Because it is controller's responsibility to push the configurations. So the latest version of the controller which is going on is 5.2. But there are previous versions 4.2. We will be using controller version 4.2 in our lab sessions, and the response is 6 ACI spine switches, right, up to this, and up to 200 ACI leaf switches. Again, it all depends upon the controller version. ACI infrastructure is well known to us. Now, I'm going to give you a quick glimpse on different ACI deployment types. The deployment which we will be doing significantly, and we will be doing hands-on exercises as well on, that is called single pod. In the case of a single pod ACI fabric, we will be talking about something like this. In our lab topology, we will be having 2 ACI spine switches and 2 ACI leaf switches. We will be working on topology wherein our ACI leaf switches will be connected to a downstream UCS B series, our rack B series chassis having various servers in it. So when we have our ACI fabric just in a single pod having multiple devices, we call it as a single pod or single ACI fabric. Multi-pod scenario is a scenario wherein this pod does handshaking with another pod as well, maybe in the same building or maybe geographically located in some other building. The connectivity between them is established through the devices called IPN devices. Now, the beauty is, though they are differently located in two different geographical locations, right? But the controllers, they still form a single cluster, that is the single family. Now, in this particular case, before coming over to understanding and configuration for this, we really need to understand how the provisioning of the devices, leaf and spine switches, happens in one single pod, one single location. Well, this is going to be part of our this particular journey as well, our ACI multi-pod. As part of our journey, before concluding our journey on ACI, we will be talking about multi-site ACI fabric. This means there will be different sites. Each site will have its own family of APIC clusters, and they will be managed from a centralized application tool called multi-site orchestrator, with the help of which we will do our configurations in all the sites of our choice. There is a systematic approach of doing the configuration, and that systematic approach is possible with the help of this particular tool. We can also call it as multi-site controller. It's so good that we have. Please go ahead.
So this multi-site orchestrator would be also kind of APIC.
It is not actually a hardware device, Aaron. This is not a dedicated hardware device like APIC, which is a dedicated server. This is an application, a cloud-based application, and can be installed in any of the server. Doesn't require any dedicated hardware.
Okay.
Right?
And I have one more question, that in
Please.
each site that APIC controller would be active or active standby?
Good question. From management point of view, which is the task of APIC controller, all the APIC controllers, they are in active states. What does this mean? This means the configuration in them, that they are the repository of the database of the configuration, right, is spread across them, and this spreading is known as sharding for the purpose of load balancing. They are all in active state, which means that in order to do your configuration, you can log into any of the APIC controller, and from there you can push the configurations. Not that you need to go only in so-called active. All are in an active state.
Okay, so does it have any interlink connectivity for syncing the configuration?
Interlink connectivity between the APIC controllers?
Yeah.
No, none of the APIC controller is directly connected to each other. They don't have port to be connected to another. No cluster interface thing. They just have, as I showed you yesterday, the node ports going towards the fabric. I'll tell you how the fabric provisioning happens, how they form a complete family, but there is no direct connectivity between them.
Okay.
Okay. So good question, Arun. Definitely more and more questions will come and they will get answered. So guys, our ACI topic will get over till ACI multi-site with the hands-on lab on ACI multi-site. Okay. Then there are various other deployment modes which have come over. For example, remote leaf. This is not part of our course which we will be discussing, but in case of remote leaf, this is basically, you can say it is a migration strategy, wherein we have one group of spine switches and leaf switches available not locally but in another field. Say we have a already existing setup called brownfield. We want it to be connected with us. So what we can call is, we can say that this is a connectivity with our remote leaf. Normally what happens? Normally our spine switches are connected to the local leaf switches. The latest version, well, it started from version 4.2 in our APIC controller. Cisco provided functionality of remote leaf connectivity, which means that our spine switches now can be connected to the remote leaf switches of a different geographical location. This is not something we have formalized yet. Another thing is another deployment, which is very well being over here in version 5.x. This is called ACI with virtual pod, which means any virtual pod you have need not be Cisco. It can be a virtual pod by VMware. Virtual pod means wherein you have the entire NSX going on, then ACI Fabric is qualified enough to connect to the virtual pod as well. Right, so just trying to tell you that our ACI is extremely flexible and scalable. Okay, now important thing, it is very important to go into our APIC controllers and understand what exactly is APIC controller. I repeat it once again, APIC controllers are nothing but they are the servers. They are the policy infrastructure servers. We call them as controllers. They are not at all involved in any intelligent activity called control plane activity. They are not at all involved in any traffic data plane traffic communication. They are just responsible for the MGMT activities. MGMT activities will include anything related to monitoring, anything related to checking the health score, the configuration health score of our leaf and spine switches, whether there is any configuration mistake. Suppose if we have done any configuration mistake, APIC controllers, they in the GUI, they can show you the fault. Well, they have got a window in which they provide you health score of each and every device, the availability status, the configuration status, etc. They are Cisco UCS C series rack servers. In front, you can see over here, there is a serial console port. If you want to log in into it locally, use this console port and connect it with your laptop. If you don't have a serial console cable, then you can go on the rear and you can connect over here as well. If you take a look on this particular position, besides having the fan trays and power supplies over here, has got two of the ports. I explained you these two ports. These are the ports which are called fabric ports and the ports which go on to the leaf switches. Leaf 1, leaf 2. At a time, it can connect maximum of 2 leaf ports, leaf switches only, wherein one port is active and another port is standby. We had a discussion about it yesterday, so I may be going little faster. Just below these fabric ports, right, we do have some other clustered ports over here. Right, and these ports are for the management purpose, MGMT. Your MGMT ports, management ports, are of two different kinds, out of band management and CIMC. Cisco Integrated Management Controller. Using your out-of-band management port, which are two in number, one is active and another is standby. Just for the sake of redundancy, we have, but we do provide only one single IP address to them. For example, 10.0.0.10, and we access this particular device using what? Using either HTTPS or using our CLI by doing SSH to this particular device. Okay, now a closer look on this. So we are seeing this more closely. So what does it do? It does configuration, right? It helps. The very first task of APIC controller is to do the configuration and push the configuration in our ACI fabric. It does management job monitoring, health function, third-party integration, which is nothing but if we need to deploy, say, 40-gate firewall, F5 load balancer, etc. That is called layer 4 to layer 7 service integration. This controller has a capability to allow us to do layer 4 to layer 7 integration as well. It is also a very important task. It is a repository of all the firmware images. All right, firmware images for what? For himself as well as for separate image for spine and separate image for leaf switches. Which means what? Which means when this firmware has a higher image, say 4.2, and leaf switches, they have image installed as 3.2, and the leaf switches connected over here. The moment you power it on, the communication happens between controller and the leaf switch. Firmware version number is checked. If firmware loaded in the controller is of version higher than that of version in your leaf and spine switches, then what he does, he immediately pushes the firmware as well without any further special instruction to him to push it. It is done automatically. Guys, remember, zero touch deployment is our holistic principle for our leaf switches and for our spine switches. We just don't want to touch. In case if we want to upgrade their firmware, even for firmware upgrade, we don't touch them. It is just the job given to the controller. So considering its importance, though is not participating in control plane and data plane, it is really very important to be there. And that's the reason Cisco has suggested that you should have minimum of 3 APIC controller in your production environment. And Arun, when you ask a question, are they in active state? Indeed, yes, they are all in active state. If the IP of this is 10.0.0.1.2 here, .3 over here, you can log into any of the controller and do the configuration. It's your choice that which controller you want to log in and do the configuration. Right now, how it actually works is something called the concept sharding. Sharding is nothing but it is a process of chopping a database into small chunks and distributing it across in the family. Right now, if you have ever gone through a simple plain concept of a RAID, redundant array of independent disks, where there is a mechanism called RAID 0. What do we do in case of RAID 0? This is called our striping. We strip the data into small pieces and distribute it. RAID 5 is one of the mechanism, and we say striping with parity, which is based on a simple equation. For example, that is A plus B is equal to C. In this particular simple equation, if any one of the variable is lost, that variable can be, for example, we do not know the value of b, so what is b is equal to, b can be calculated with the help of c minus a. Well, the sharding concept is based on the same sharding concept, which runs in our APIC controller, says that whatever data comes, that data will be broken into, will be sharded into and distributed among various controllers, so that in case if any of the controller goes down, the data will still be saved in this. Even if two of the controllers they go down, the data will still be recoverable over here. The only catastrophic situation will be, which should never occur, is all the three controllers are down. In that case, only management plane will be impacted, not the data plane, not the control plane. Suppose if all three controllers are gone down, then what? Then bring new controller with certain same initial setups, connect it, and will fetch the information, all the configuration information from your leaf switches so connected. That is the beauty of it. So this provides us extreme reliability and redundancy in our network. So we can enjoy 24/7, 365 days service without any issue. All right, more clearer understanding of APIC controller is still required. This is not enough. Well, APIC controller has gone through a long journey. The journey started approximately a decade back, right? And in the journey of various version, it has gone through. The current version is 5.x. Now, in this particular journey, it has gone through various evolutions. For example, I told you addition of remote leaf, virtual pod. In version 3.x, Cisco introduced the capability of controllers to be connected to our fiber channel networks as well for the purpose of storage. In version 2.x only, Cisco introduced the multi-pod configuration capability in our controllers. However, in version 1, the multi-pod connectivity option was not available. So any change in the major release came along with some major enhancements, feature enhancements in the controller. Datasheet can give us more granular information about it if you want to go for a specific version. Now version 3, how it used to look like. Version 4.1, the controller version which we shall be using, guys. Let me give you a glimpse of it available with us right now. We are in the deep cloud. One lab, the very first basic lab which we will be doing is this one. I have already booked this particular lab for the demonstration purpose. So I just need to click view. Yes, lab is coming up. All right. Workstation. I'll give you a complete walkthrough of this particular, what all do we need to do in the very first lab session. Over here, the intention is just to show you a glimpse of it, right? Currently, the fabric in this particular lab is not at all initialized. The very first task of this lab is to initialize the fabric. This particular lab will provide you remote desktop, a Windows remote desktop, wherein you will have the controller icon on your desktop itself. So this is APIC login. Just by clicking it, you will get into the APIC, Application Policy Infrastructure Dashboard. But before it will ask us to specify the username and the password, and the username is admin and password is Cisco 12345. Kindly take a note of it. The version it is showing as 4.23q. I'm going to log in into it. As I said, this particular controller is yet not have provisioned the entire fabric. That's the reason the very first welcome window says begin first time setup. I'm just going to skip it, right? Do not show this. And if I go to the dashboard, is it not? Why it's not allowing me? Okay, begin first time setup. It is forcing me to do the first time setup, and I'm just going to close it. Now, in the current state, I will not be able to see any node. The only controller which I can see, though we have availability of 3 controllers, what is expected for us to do as a very first step is to get our nodes over here. That means what? We expect to see over here our spine switches and our leaf switches. Number 1 point. We also expect to see over here under controller status not one single controller but 3 controllers over here, and they should be, all of them, they should be in service, health available state and fully fit healthy state. Since I cancelled the first time setup, that is called fabric provisioning, that's the reason the dashboard, now which tab, main tab is system tab and sub tab is dashboard tab, is showing us absolutely a blank status, only a controller over here, right? So in the very first lab of ours, we will do the fabric provisioning to make sure that our leaf, spine and 2 more controllers can be seen over here. And when we can see all the controllers, this means they have formed what? A cluster. There is a sequence which happens before even stepping into it. We will make sure to understand and talk about each and every protocol as well, because the sequence happen based on the protocol. So I'm just keeping it as it is to be done later on. This is our GUI of our APIC. It's back over here. APIC, some important points. The very first important point about APIC is it is nothing but it is a database storage. Second point, it comes as a UCS appliance, unified computing system. It is basically a server. In production, minimum 3 APIC controllers are required. Otherwise, if one single controller is there, that is gone, boom, your entire management plane is lost. Traffic will not be impacted because you have data plane and control plane running in your leaf and spine switches. It can be integrated. The word should not be, should be integrated. It can be integrated with various automation tools using RESTful APIs, and it can be integrated with orchestration tool like Cloud Center. It can also be integrated with our VMware vCenter server. What is vCenter server? We have a lab, a detailed lab on what is vCenter server. But before that, there will be an explanation of server virtualization. There will be an explanation of network virtualization, which is required. So this means once it is integrated, once APIC controller is integrated with our VMware vCenter server, this means whatever he is doing, the same thing can be done from vCenter server as well, using something called APIC plugins, which are downloadable. We can download and we can install in our vCenter server, and we can manage our controller from vCenter server. So look at the cohesiveness which it is expanding to. It says you can manage me from other tools as well. I'm ready to do handshaking with other tools, other orchestration tools as well. As I said, it is a holder of all the firmware images. So why not to take a quick look back onto our controller? Where are the images stored? If we go to the admin tab, right, and if we look at into the firmware, right, so we can see the firmware version is mentioned 4.2.3Q. Now firmware for the controller is this. If we click nodes, currently no nodes available. If you click over here, see we are in infrastructure controller tab. For the purpose of controller, which controller? The firmware is over here. Since the nodes are not being discovered, so that's the reason he is not showing the firmware of the nodes. Once we will do the fabric provisioning, he will show the firmware versions as well of the nodes. So what we normally do is, in case if we need to upgrade, we first of all have to install, we have to load the firmware version over here, and then we can do upgrade as well. So APIC controller is a repository of images as well, firmware images as well. What else? No traffic goes to the APIC controller, means it is not at all participating into data plane. APIC, some important point. Now, the important point about APIC, what it does, it, as I said earlier, monitors. Instead, it monitors the delay packet loss. It monitors the health score of the devices. Now, important thing. The very first and the foremost important thing is how APIC controller pushes the configuration onto leaf and the spine switches. It happens by the virtue of a protocol called Flex protocol. But guys, let me tell you one simple thing. Even before this particular protocol, the first and the most important protocol is LLDP, Logical Link Discovery Protocol, by the virtue of which controllers, they do handshaking with the leaf switches. They acknowledge that yes, they are connected with the leaf switches. And once we do certain configuration in our controller, then Flex protocol helps to push those configurations to the leaf switches. From leaf switches, they go to the spine switches and get spread across the entire fabric. Flex protocol is, of course, a protocol which is supposed to push not only the configuration for ACI leaf and spine switches, but for some other devices, both virtual and or the hardware devices. So this Flex protocol is a joint efforts of multiple vendors, wherein we do have Cisco, Intel, Microsoft, Red Hat, VMware also is there, Citrix, F5, Canonical, Ambient, blah, blah, blah. Why? Because we don't want to make it only specific to Cisco devices. Now, the traffic, about the traffic which it pushes, what he does, he makes sure the traffic is encrypted and move along with the certificate, which ensures the reliable delivery of our management traffic to the leaf and the spine switches. Finally, APIC controller, as we use this terminology multiple times, ensures a zero-touch deployment, zero-touch provisioning of entire fabric. You know what? When I'm saying zero-touch installation over here, I'm also saying for the purpose of assigning out-of-band management IP addresses to your fabric nodes, means leaf and spine switches. Forget, you need not touch your leaf and spine switches. So the very first lab, as I said, this particular lab which I stopped, in this particular lab you will see the sequential flow of fabric provisioning, and in this particular lab you will see that how controller is going to provide the IP addresses, the out of band management IP addresses to the devices as well. This particular lab we will be touching very soon. Okay, so Opflex we have understood. Pretty important protocol, but remember, before any protocol to work, LLDP is the master of all the protocols. APIC interfaces. You can manage your APIC controller. Predominantly, we do it using our GUI, graphical user interface, as the one which I showed you. You can also do SSH into your APIC controller, and you can get the CLI access of the controller. Not only this, using your RESTful APIs, application programming interface, REST stand for representational state transfer, right? Which are nothing but which are the plugins to connect your APIC controller with your fabric, with APIC controller connected to the fabric with your scripting languages like Python, Ansible, Postman, etc. Right. So you can manage. This is GUI, the one which is there in our hand. This is SSH you did. Then Postman is Google's tool to manage the controller and manage the network. Then there is a language, Ansible, Python, and UCS director is an orchestrator. Now it is replaced by something called Cloud Center, an orchestrator. Besides this, I also told you that VMware vCenter server, by installing plugins, you can manage your ACI fabric from there also. It requires a handshaking, and this also we are going to do in the same beautiful lab what we have. Okay, not many things are going to come. So let us once again start from the scratch. And when I'm saying start from the scratch, means we are not at all going to leave APIC controller unless and until we fully dissect it. So more closure view of our APIC controller rear side, because rear side tells us. This is I discussed yesterday again. This is what written. All right, this is written as two fabric. What ports? One port, two port. Where they are going to leaf 101 and leaf 102. At the time, one is active, one is standby. These ports are bond ports. We call them as, say, bond 0. Then we have the ports over here. These two ports closer to each other, they are our out of band management interfaces. The port next to it is our CIMC, which is nothing but which is an analogous of ILO port in our HP servers. Integrated lights out, and this is Cisco integrated management console. The big question comes is purpose of this. This is fine. With the help of this particular port, we just happen to log inside our controller and we were having a GUI access. With the help of this particular port, we do get the SSH CLI access of controller, and we can do the configuration from there as well. So this particular port is for the holistically for the purpose of management, means for the purpose of doing and pushing the configuration inside our ACI fabric. But this particular port is not for the purpose of configuring our ACI fabric. Using this particular port, SIMC port, you cannot provision your fabric, right? Okay. So the purpose, then what is the purpose of this port? And more closure. So if you can see this particular port, this is, for example, this particular cable is going and connecting to leaf 101, and this cable is connecting the controller with leaf 102. So how many controllers do you see over here? 1, 2, and 3. So these 3 controllers are for the purpose of what? For the purpose of providing redundancy. And these 3 controllers, they are going to form a cluster. Once the complete fabric is provisioned, remember, they do not form the cluster immediately once they get powered on. They can form the cluster only if the complete fabric is provisioned. There is a sequence, and yes, we are going to do it in our lab. We can see over here this particular, all right, this particular port out of band management. We can see one cable is coming out of, it is green, and this particular is our CIMC cable. Where exactly this cable is going? This particular cable is going to our management switch. What for? This port is for the purpose of T shooting and not for the purpose of pushing the configuration inside our ACI fabric. T shooting what? T shooting in case if we happen to see that one of the controller is not available, is not in a fully fit state. So we want to fix the issue. For example, even the management, some addresses are incorrectly being placed. So for that particular purpose, we do use these ports. Over here, this port is this cable is going to your MGMT, and the cable over here is going to your CIMC. Both of them, let me tell you, the cables are going to your management switch only, which means the IP addresses assigned to them will be from your management block only. So this I would like to tell you now shortly with the help of a table. More closer view, it is clearly written to fabric, leaf 101, leaf 102. Where this port, there is a management switch active, and this is standby going over here. It is not mandatory to have connected over here. SIMC, if you want to do a remote troubleshooting, then only connect it. Otherwise, connecting your management switch with SIMC is also not mandatory. But it is, yes, it is indeed when you want to fix some issue. All right. So guys, one beautiful thing which Cisco dCloud is providing, though we do not have hardware tools right in our hand, Cisco is providing us a video wherein you can see the controller first time setup. I repeat, the first time setup of your controller. Absolutely, you just unboxed your controller, you mounted in your rack, plugged the cable, power cable, it is on. Before powering it on, what you did on its management port, say in front, which is serial port, you got your laptop connected. Or in case if you don't have a serial console cable, then go on the rear side, there is RJ45 console port you can connect over there. Before it, as we know very well, we need to use hyper terminal or even M-putty you can do, but you have to do the basic port settings about baud rate, about the port and all those settings in CCNA. Probably when you did your CCNA and you connected your laptop first time with the hardware, you did the same thing, right? So your laptop is connected to the port and now it is powered on. The moment you will power it on, one window, not window, one CLI options will come in front of you. That is called controller first time setup. In the controller first time setup, you have to give two different kinds of information. One is called cluster configuration, other are called out of band management information. This cluster configuration information are nothing but to ensure that two or more than two controllers, they can form a cluster, a family with the similar information where and as required. I would recommend you to go through this video. This video has a problem because the window is very small. So you really have to zoom it and to see. Quite difficult. I tried once again watching it, but difficult. Now let me tell you various information which you need to provide and make sure that the information which you're providing in these three controllers, they are similar wherever required. For example, the fabric name. On each and every controller, you have to provide a fabric name. Make sure the fabric name is same, which is name of the ACI fabric. Well, then number of controllers. Yes, the number of controllers which you want to form a family. So you have to specify the correct number of controllers as you have with you. And same information to be there in all the controllers, guys. Please make sure the information are same with no differentiation over here as well. Controller ID. Now this information could be 1, 2 and 3. You can say this controller is having an ID of 1, 2 and 3. Fine. Now controller name. You can say this controller name is APIC 1, then APIC 2 and APIC 3. Different. Fun. Now then, very important information that is called tap address pool. Tap, tunnel endpoint. Who are the tunnel endpoints? Our leaf and spine switches are tunnel endpoints. Guys, let me tell you one thing. These controllers, right, they are just not the management servers. They are also the servers which play a very significant role, of DHCP. They are also DHCP servers. They are the servers who are responsible to provide dynamic IP addresses to the fabric nodes, that is leaf and spine switches. Because as we said, we will not be touching our neither any of the leaf nor any of the spine switch. But IP addresses need to be provided to them. Who is going to provide IP address? A DHCP server. Who is a DHCP server? These controllers are DHCP server. As when we configure a DHCP server, we create a pool of assignable IP addresses. This address tab pool, which is mentioned to you as default, you can just click enter. It will be executed. This is the address pool, which is your DHCP address pool, and the IP addresses to your fabric nodes will be provided dynamically from here itself, and that too sequentially. Right now, then since our ACI fabric nodes, they are going to create one particular infrastructure, so there is a provision to provide one infrastructure VLAN ID to recognize all the devices under a single infrastructure. VLAN ID is indeed .1Q VLAN ID ranging from 1 to 4093. Do not take the reserved VLAN IDs. Cisco's recommendation is to take 3967. Rest is your choice if you want to take any other. But make sure the VLAN ID so used should not be used by you for the configuration. The last but not the least important information which you need to provide is the multicast address, which is known as group IP out. This is called group IP address. A default is provided, right? You can just click enter over here. In the very second lab, I will show you the purpose of it. In our multi-pod lab as well, I will show you the purpose of this particular group IP address, what actually it does. With these holistic configurations for the formation of our cluster, if pushed, then we will come to the out of band management configuration, but for the controller itself. This over here, you have to provide the management IP address to be assigned to the controller, just specify over here, and the gateway just specify over here. Before finishing the configuration, it will request you to provide a password and confirm the password. Done. Your controller is now ready. Same configuration you need to do in your other controllers, right? Plug them up. But my dear friends, these three controllers, they are not immediately going to form a single family that is called cluster. Cluster formation of these controller is dependent on what? The fabric provisioning. That means now then they holistically need to make sure that all the leaf switches they are connected to, right? They are provisioned, and along with the spine switches are also provisioned. Once the addresses are provisioned to them in a sequential manner, they also get discovered, right? For example, you have started your journey from this controller. After fabric first time setup, in fact controllers first time setup, then one by one sequentially your leaf and spine switches will be discovered, and finally then rest of the controllers will be discovered. Once rest of the controllers get discovered, then cluster gets formed. Hope this is clear. Seems theoretical, but practically we are going to do it to a good extent. I'm not saying to 100% extent, because we do not have controllers as hardware in our hand. We do not have we are not in a close proximity of the controller to do this fabric initial setup, but the lab which is being provided to us, that particular lab is sufficient enough to look at in the sequence how the fabric gets provisioned. All right, now something before we end for the day, let's look at into now the real utility of SIMC, Cisco Integrated Management Console, not a controller. For example, we have a cluster. We want to form a cluster of 4 APIC controllers. What is there? All right, 3 controllers, not 4. One of the controller, though we have done the configurations individually, first time setup configuration on all the controllers, we plugged all of them, and in our graphical user interface window under system dashboard, we can see a controller here, right? But it is shown as not in a available state, but it it is shown as red and unknown state, and it is not fully fit. Guys, in case if you happen to see the controller which is not in a fully fit and health score is not 100% available, you should immediately stop. You should not go and start doing configuration for your ACI fabric, that is for your leaf and the spine switches. Why? Because any configuration revision number variation may wipe out your latest configurations as well. So any controller, if it is not available, you immediately have to fix the issue. And this is, in short, we call it as an APIC maintenance. This APIC maintenance is done with the help of our SIMC port. So if you have provided IP address on SIMC interface, then you can remotely fix the issue. In case you have not provided, then I'm sorry, you have to provide IP address, management IP address on the SIMC. You please request your local data center hand and eye support. Tell him how to configure the SIMC IP address, and then you can get the remote access of the controller to fix the issue. That is Fabric first startup configuration issue. Now, this is a diagram which is over here just for the purpose of telling you that your Fabric ports, that your management ports, they are bonded together. I'm sorry, the two of the Fabric ports, they are bonded together. Two of your management ports, they are bonded together in bond 0 and in bond 1 respectively, which makes them as active and standby here, active and standby here. Now, suppose you want to configure your SIMC IP address. When you first time plugged your laptop or desktop with the console, using console cable with the controller, you did all the configuration, you provided management IP address to the controller as well. But you want to provide IP address, management IP address to the SIMC. So you have to break the boot sequence. You have to go into the BIOS, just like, with regards to your desktop, you can break the sequence. Here, you just need to press F8 key when the post power on self-test is going on, right? In your server, immediately press F8 and it will take you to the BIOS. So this means SIMC IP address is specified in the BIOS settings. It will take you to the BIOS and where you can see the IP address if provided. If it is not provided, then you can provide the IP address to the SIMC. You are in SIMC configuration utility version 1.7 Cisco System Incorporation dialog box. Now you can provide SIMC IP address using DHCP, not at all advisable. To the servers, we don't advise to provide a dynamic address because we really need to know what exactly is the IP address. It should not get changed. You can provide SIMC IP address over here with the subnet mask and with the gateway. Done. Your SIMC configuration is done. Assuming now that SIMC configuration is done, now you want to fix the controller's health issue. You know what? Before it, this is a table just to tell you and give you assurance that we have got 3 of our controllers having their respective out-of-band management addresses. They also have got individually SIMC and SIMC addresses are to be assigned. This is not, of course, with regards to our lab. This is just an example where And the purpose of this example is to tell you that the SIMC addresses are from the same management network. You need not have a separate management subnet to provide IP addresses to SIMC. This means that both SIMC port and management port, they are connected on the same management switch, right? With the username and password. Now, coming over to the APIC controller's health issue, which is found to be not in 100% healthy state, not in a fully fit state. Now, we are given responsibility to fix it. We know that IP address of this particular controller is there both outer band as well as SIMC. So you know what? Using our browser window, we can do HTTPS to the SIMC IP address of the controller. The default username and password is this. Default username is admin and default password is password itself. Type it and you will get to see this particular window. In this particular window, complete details are provided. Stay yourself in the server tab. You will happen to see launch KVM option over here. KVM stands for what? KVM, keyboard, video and mouse. This is nothing but you get the keyboard of your controller, the video look of your controller, and you can operate your mouse as well. The moment you will click the hyperlink KVM, launch KVM console, you will get into this particular window. And you know what this window is? This is the same window which we do get when we first time plug our laptop or desktop with the controller. That means what we do get is we do get the console of the controller, and this console of the controller will take us to the same page. This is your initial setup page, the cluster configuration, the outer band management configuration. In case if any mistake is being done with regards to these configuration in comparison to his cluster peers, right, we need to correct the information over here, save the information, and with the correct information, this controller will come back into 100% available and fully fit state. You know what? You should ask a question. How would we judge that this particular controller has certain misconfigurations being done? And you know what? In order to do check what misconfigurations are being done in this particular controller, you have to go log into a healthy APIC controller using your CLI SSH to its mgmtip, execute a command ACI diag AV read ACI diagnostic appliance vector read. What is appliance vector? What is A? A stands for appliance. In ACI, the controllers are known as appliances. The leaf and the spine switches are known as fabric nodes. In short, we call them as FN and vector, FNV. In case if you want to read the information with regards to the fabric nodes, then the command changes to ACI diag, FNV read. If you want to read the basic information, configuration information done in your appliances, that is your controllers, then the command is ACI diag AV read. By executing this command, you get the complete configuration of all the three controllers, which means healthy as well as unhealthy controller. You just have to compare them, compare what configuration is incorrectly done in the healthy controller and what is the correct configuration in the healthy controller. Go back to this, put the correct configuration, give the password and save.
Yeah, I should have one doubt. So fabric name should be same on all controllers, right?
Absolutely. Fabric name should be same. So couple of things which should be same, like your fabric name on all the three controllers. Name of the ACI fabric should be same. ID, enter the fabric ID. It should be same on all the three controllers. Number of active controllers should be same on all the three controllers. Pod ID, it should be same because they belong to the same pod. We are not doing a multi-pod scenario. In case if it is a multi-pod scenario, it should be different. Is this standby controller? There is no concept of standby controller. You just press enter over here, enter the controller ID. Now it should be 1, 2, and 3 different. Right? Controller name, it should be different. Say name is 1, 2, and 3. Normally we say APIC 1, APIC 2, APIC 3, your choice. Tab pool, it should be same on all the three controllers. Right? Infra VLAN, it should also be same in all the three controllers. Tab pool called GPO address, it should be same on all the three controllers. Right? Management IP address need to be different, of course. The gateway should be same on all the three controllers. Right? This particular window is also the same window which we do obtain by connecting our controller from console. Since we are not locally and closely in touch with the controller, we need to fix this issue remotely. That is the reason we are taking the help of CIMC port, with the help of KVM is capable to give us the same console access to the controller. My pen is down, guys. Sufficient, I think it is for the day. If you have any question, then of course I am with you, for you always. This was asked yesterday also. Yesterday, yes, it was a premature state to discuss about it. Now we have discussed. With this particular thing being done, we will be in a good position to go for the next part, which is called fabric discovery. And if I'm not wrong, tomorrow, yes, we can discuss that as well. All right, question, please.